Welcome to Oryx Learning. Today's lesson is on Unit 5, Functions, Lesson 4, Linear Functions. Fatima is saving money for college. She already has $1,000. She plans to save another $250 per month. How could Fatima create a table and graph that would display her savings for the next 4 months? If you would like to see the table and graph, follow along and we'll revisit this question at the end. A linear function is a function in which the graph of the solutions forms a straight line. A function can be considered continuous or discrete. Continuous data can take on any value, so there is no space between data values for a given domain, represented on a graph with a solid line. Discrete data have space between possible data values, represented on a graph with just points. No line is drawn. When representing a function, we can represent it in words. For example, the value of y is 2 more than the corresponding value of x. We can represent it in an equation, y equals x plus 2. We could represent it in a table, where x is our input. Our function rule is x plus 2, and our output would be the y. Or we could represent it in ordered pairs in a graph. Which of the following describes discrete data? The volume of water in a glass, the weight of a rhinoceros, the length of a song, or the number of chocolate chips in a bag? The correct answer is the number of chocolate chips in a bag. Remember, discrete data are individual points, individual chocolate chips, instead of a continuous value, like the weight of a rhinoceros, the volume of a glass of water in a glass, or the length of a song. Which graph represents the function y equals x over 2 plus 3? If we go back to our slope-intercept form of an equation, y equals mx plus b, m is the slope, the coefficient of x, which in this case is 1/2. B is the y-intercept, which in this case is 3. So we're looking for a graph that has a y-intercept of 3 and a slope of 1/2. The second graph is the correct option. As we can see, the y-intercept is 3. From the y-intercept, if you go up 1 over 2, the slope, another point on the graph exists. Complete the table below for the given x values in the function y equals 5x minus 3. So we need to substitute in a 4, 5, 6, and 7 for x in the original function. Substituting a 4 gives us 5 times 4 minus 3, or 17. Substituting in a 5 would give us 5 times 5 minus 3, or 22. Substituting in a 6 would give us 5 times 6 minus 3, which is 27. And lastly, substituting in a 7 would give us 5 times 7 minus 3, or 32. A snack stand is selling hot dogs for $1 and hamburgers for $3. Maura has $18 to spend on food for her group of friends. The function y equals 18 minus 3x represents how many hot dogs y and hamburgers x she can buy. Graph the function and complete the statement. If Maura buys 4 hamburgers, she can buy blank hot dogs. So in order to graph the function, let's fill in our table first. Substituting in a 0 for x, I'll get 18 minus 3 times 0, or 18. If I substitute in a 1, I get 18 minus 3 times 1, which is 15. Substituting in a 2, I get 18 minus 3 times 2, which is 12. And substituting in a 3, I get 18 minus 3 times 3, or 9. Plotting these points, I get the following graph. I can see that when Maura buys 4 hamburgers, she can buy 6 hot dogs, as the point 4, 6 is on the graph. An office supply store sells packs of pencils for $3.50. Write a function that represents the total cost y of any number of packs X of pencils. Then make a table of the values for the total cost of 1, 2, 3, 4, and 5 packs and graph the function. The slope of our line is 350. So we have y equals 3.5x. Putting this in to my table, I can substitute in the values of 1, 2, 3, 4, and 5 into the function y equals 3.5x. So substituting the 1, I get y equals 3.5 times 1, which is just 3.5. Substituting in the 2, I get 3.5 times 2, or 7. Substituting in the 3, I get 3.5 times 3, which is 10.5. Substituting in the 4, 3.5 times 4 is 14. And lastly, substituting in the 5 gives me 3.5 times 5, or 17.5. Now that I have these points, I can graph my equation. So this is the graph of the coordinates found in the table. Back to our college savings. Fatima is saving money for college. She already has $1,000. She plans to save another $250 per month. How could Fatima create a table and graph that would display her savings for the next 4 months? If we let X represent the number of months and Y represent the total amount saved, then we can form the equation Y equals 250X plus 1,000, as 1,000 is our initial amount, and the slope, the amount of change, would be 250 per month. Substituting in X for the next 4 months of 1, 2, 3, and 4, I get the following: 250 times 1 plus 1,000, which would be 1,250. Substituting in a 2, I would get 250 times 2 plus 1,000, or 1,500. Substituting in a 3, I would get 250 times 3 plus 1,000, which is 1,750. And substituting in a 4, I would get 250 times 4 plus 1,000, which is 2,000. So that would be the function represented in table form. Now to graph it, I can plot my ordered pairs to get the following graph. Remember, when representing a function, there's multiple ways we can do it. One way is in words. For example, the value of y is 2 more than the corresponding value of x. We can represent that in an equation, y equals x plus 2, in a table with ordered pairs 0, 2, 1, 3, 2, 4, 3, 5, or we can graph those ordered pairs and make a graph. That is our lesson for today. Thank you for joining us, and I hope you enjoyed it.